So let's see its principles and what it helps us to achieve. So basically it defines the skeleton of an algorithm in a method. So what does it say? It says is that suppose in order to achieve any task, there is series of steps that needs to be performed. Step 1, 2, 3, 4, 5. Then this series of steps, which is my algorithm, it defines its skeleton in a method. So it defines, okay, first step 1 has to be performed, then 2 and 3 and so forth. Secondly, it lets the subclasses redefine the steps of algorithm without changing the structure of the algorithm, which means my subclasses can redefine or override the step 1 or step 2 or any of the steps in the algorithm, but it won't change the skeleton of the algorithm, which means that after my step 1, step 2 will be performed, then step 3 and so forth. It also provides the hook for some default steps in algorithm, which means that my subclasses will choose to perform any or of the specific step, or they might choose not to perform that specific step in the algorithm. So we'll try to see this with help of scenario. So we have to design a travel booking application which books tickets for flights and trains, and few of the steps of booking ticket is same, but few differ in actual implementation is specific to flight or the train. So let's see some code for it. So let's see this class, travel booking class, which is an abstract class, and it has a method called book travel. And in order to book any travel, I need to perform a series of steps. So first, when the user is going to log into my application, I need to check the login credentials. Then I need to get the traveler details. Then I need to book the tickets. Then I need to add meals, and then if user wants, then I need to add the insurance, the travel insurance. Now if I try to relate this with the principles of template method design pattern, then this is my algorithm. These are a series of steps which will be performed, and few of the steps are common, such as check login credentials and get traveler details. So whether the user is booking a flight ticket or a train ticket, he has to go through these steps. Then few of the steps or methods are specific to the actual implementation. So book tickets, add meals and add insurances will have a specific implementation based on the mode of travel. So the process of booking tickets will be different for flight and will be different for train. Similarly, adding the meals will be different for flight and train, and adding insurance will also differ for flight and train. And I talked about a hook method. So this is that hook method, need insurance. So I will try to explain how it is implemented, but let's see the common methods. Check login credentials. So this method is will be defined in my abstract class itself, because it is common for all the implementations, or for all the subclasses who are going to extend my abstract class. Similarly, for get traveler details, it's a common method, so I'm going to define it in my abstract class only. But this book tickets, add meals, and add insurance will be the abstract methods in my abstract class. Coming on to this hook method, need insurance. So I'm going to provide a default definition of this need insurance. So it's going to simply say true. So by default, the need insurance will be true. If my subclass wants to selectively choose the whether it needs insurance or not, then they will have to override this method. So let's see one of the implementation class, which is flight booking, which extends travel booking, my abstract class, and it is overriding these three methods which are specific for flight booking: book tickets, add meals, and add insurance, and providing its own definition: booking flight tickets, adding meals available in flight, and adding insurance applicable for flight. It also overrides this hook method, need insurance, wherein it's going to ask the user whether the user needs the travel insurance or not, and based on the reply of the user, if he says yes, then it's going to return true, or else it's going to return false. And looking at the train booking, so here also it overrides these three abstract methods and providing its specific implementation: booking train tickets, adding meals available in train, and adding insurance applicable for train. But if you see here, it is not overriding the hook method, which is need insurance, which means whenever user is going to book a train ticket, then by default uh, this is going to return true and insurance will be added. Whereas in case of the flight booking, this hook method need insurance is getting overridden, so user will have a option to either go for insurance or not. Okay, so now let's run this classes with help of some test class. So here first I'm going to book the flight ticket. So here if you see, I'm creating an object of flight booking, okay, and assigning the object to a reference which is my which is of type of my abstract class, and this flight booking extends this abstract class travel booking. And then I'm going to simply call the book travel method. So this book travel method is present here in my abstract class, and it's going to trigger this algorithm, a series of steps in the algorithm. So let's run this and see. So if you see, first it says checking traveler login credentials, because in my algorithm I have said first check the login credentials, which is a common implementation. So it prints this checking traveler login credential. The second line says fetching traveler details, because in my algorithm the second step is to get the traveler details, which is again default, and it's part of this abstract class only. So it says fetching traveler details, then it says booking flight tickets. So the third step was book tickets, which was the abstract method here, because this step is specific to the implementation class or the subclass. So my flight booking class overrides this book tickets with its own implementation. So it says booking flight tickets, right? And the third the fourth step was add meals. Again, it was abstract, and here it says adding meals available in flight. So this implementation is specific for flight. Okay, so it prints that. Now if you see, it comes here, need insurance. The default definition in the abstract class was just to return true, but because this hook method need insurance has been overridden in my subclass, which is flight booking, so it executes this piece of code, and it is asking me need travel insurance. So based on my input, if I say yes, then it returned true, and since this turned out to be true, it executed this add insurance, which is again overridden in my flight booking class, add insurance, and it prints adding insurance applicable for flight, and at last it printed travel booked, right? If I run this again, and this time need travel insurance, which again came from this hook method implementation for flight, if I say no, then if you see, it turned out to be no and false, and this was not executed. So this didn't get executed. Add insurance, this didn't get printed, and it simply says travel booked, right? Coming on to the train booking, similarly, if I just change it to say train booking, and if I execute this, so if you see, same thing happened again. First check login credential, printed this, then fetching traveler details, then this thing got executed, book tickets. So the implementation is specific to train booking was executed. It printed booking train tickets, then adding meals available in train, then now it printed adding insurance. Why? Because I'm not overriding the hook method here. I'm not overriding the need insurance. This method I'm not overriding in the train booking.java. So its default definition was to return true. So it returned true, and by default add insurance method got executed, which is abstract here, and overridden in my train booking add insurance. So it printed out adding insurance applicable for train, and finally it printed this travel booked. So now if you see the use case, then what happens is, whenever you come across designing an application, and to achieve a specific task, a series of steps has to be performed, or a series of methods needs to be executed, and there are different types of ways in which these methods can be executed. Then you can go for this design pattern wherein you declare the skeleton of the algorithm in your template method and keep it inside an abstract class and let the subclasses choose its specific implementation for all those methods which needs to be implemented in a specific way by a specific subclass, and let all the common methods be a part of your abstract class. And if in this skeleton of algorithm there is a step which should not be always executed, then keep it under a hook method and let your subclass decide through its implementation of this hook method whether it needs to execute that step of the algorithm or not. So that is it about template method design pattern. Hope you got the um, scenario in which you can use this and how it can be implemented. Thanks a lot.